Welcome to this session of the Tech Forum. My name is Rodolfo Lomascolo, and I am the CEO of Pervasive Technologies. Pervasive Technologies is a company that creates AI solutions to improve operations, adding intelligence using data, videos, and images. Our company is based in Barcelona. We have offices also in Madrid. Our team is of 14 people. We are 15 data scientists. And what we do is we create, as I said, solutions based on videos and images applying artificial intelligence. Our customers are in Europe and in other parts of the world. And we work with a network of partners that deliver and integrate our solutions into customer processes. We have been awarded some prizes and in competitions around artificial intelligence, and one of our main partners is ADLINK. So we have developed a methodology to approach this kind of projects, specifically for industry and retail, with a proprietary platform that we call Heureka. And in Heureka, we create vertical solutions for different pains, for different needs in retail and industry. We have partnerships apart from ADLINK with NVIDIA and Google Cloud, because our solutions combine artificial intelligence in edge with cloud, with different levels of weight on each side, many times more edge than cloud, and other times more cloud than edge. And our team is very specialized on these kind of solutions. Some customers that we have are Spanish and from Europe, and we have developed for them solutions in, as I said, retail and industry. Today, we are going to talk about retail, so I will concentrate my speak around this. So what we do, in general, we work in industry around security and safety solutions, also in asset control and surveillance. We do a lot of intelligent OCR that we call ICR, intelligent character recognition in documents and in extreme environments. And we also do AI analytics. For retail, AI analytics is CPG analytics, that is recognizing products in shelves and in stores. We do planogram analysis, price analysis, and product execution analysis. All these based on images and videos. So in retail, what we expect in retail for the next years is a change in the way we analyze the information in the shelves and the information that come from the customers to improve business processes. Everybody thinks today that we will have solutions that will help those processes to be more efficient. Many new business models will be created. We will talk a little bit more about this later in my presentation. And new products and services will be created in retail using tools and solutions based on artificial intelligence. The problem with AI today is that many times to create new solutions, we have to work with an approach that is iterative. That is because we have to develop models that many times don't exist, or that many times have not been used for the objective that we have in the project to solve the problem. And this kind of approach requires that the projects and the solutions move by different phases. For example, in our case, what we do is we have divided all the process for this kind of project or solution creation in 5 steps. First step is what we call a lab. When somebody approaches us with a problem that wants to solve with AI applied to images and videos, many times we don't know if we will be able to extract information, to extract value from those images and videos. So our first approach, our first step is to develop what we call a lab. In a lab, we do an analysis, a technical analysis, and we work with the images of the customer to try to extract information, to be clear, to pass those images, those videos by models to see if we can extract the information that we need to solve the problem. So if it's a detection, we try to detect the objective. If it's a localization, if it's a segmentation, depending on the problem that the customer wants to solve, we try to approach this problem with a very simple, with a very fast laboratory approach. This is done in days, so we spend 4 or 5 days working with the data of the customer to try to extract the information, to have a minimum value that we can extract from that information. We get a baseline. So we know if it's going to be possible to improve or not the output. For example, if from the data I have, I can only extract 15% of the objects that I want to detect, it's going to be difficult to move from 15% to 99%. So this is a difficult case, and in many times after the lab, we say there is no value in the data, that it's not easy or it's not possible to extract the information you want to extract from this data, from these images, so we don't see that this can be done. If it's the case that from the lab we extract a value around 40, 50, 60% of the objects that we want to detect, we extract value from those images and videos, we can move to the following phases. We can say, yes, we see that with a small effort, we have worked with your data, we have extracted information, there is value there, it can be extracted, we can move to the next phase that usually is a POC, a proof of concept. But before the POC, number 3, we work with the customer, analyzing the problem, analyzing the data he has. We do an assessment to try to capture more information from the data, to modify the data, modify the way the data is captured, to try to have more value in it. We also try to understand the problem in more deeply, because we must understand really which is the question that must be answered to develop a system that can extract information to solve that problem. So after phase 1, we have phase 2 and 3, the assessment and the POC. In the POC, we also work in our laboratory, but we work with more images, we train different models, we try different approaches, and we spend more time, many times weeks, in some cases months, to develop the solution that extracts the information that is valuable to provide an answer to the problem that the customer has. From phase 1 to phase 3, we work in our premises, we work in our laboratory, but at the end of phase 3, we have a solution, a module, a model, or a group of models that can provide the answer to the question that the customer posed. So we can move to the phase 4. That's what we call a pilot. In a pilot, we work with the systems of the customer. So our solution moves to the customer premises where it is exploited, it is run in parallel to the system that the customer already has. Or if there is no system, in the pilot, the solution runs with the control being controlled by somebody. That way we can check, we can validate that the solution we develop in the POC phase works correctly, and many times what we do is we retrain the models, because many times the actual real images from the customer are not the same that we have recorded. Many things can change. The scene of the images, many things can change. So in the pilot phase, we run at the customer premises, but we also do work of retraining, relabeling, capture of more images, more data, better models to have at the end of the pilot what we call a minimum viable product or a minimum viable model or module. So at the end of the pilot, what we expect is to have a solution that can be run in production after being validated in this pilot. So we move to the phase number 5, where we have production. After phase 4, our solution can be installed in the customer premises without validation, because it's already validated in phase 4, so it can work freely. And what we need to move from phase 4 to phase 5 is to industrialize the solution. Industrialize the solution means many times to install it in a device that is industrial grade, that can work on high temperature, that can work 7 days a week, etc. So in production, we have to make sure that the solution can run without interruption in an industrial environment or in a retail environment. These are the five phases that we walk during the process from the question to the answer to the problem of the customer. So this is applied always in every project or in every solution that we approach. The problem is that many times, many solutions don't move from the lab, don't move from the POC, or don't move from the pilot to production. Today, around 50% of projects don't move from pilot to production. Many times because of poor results, of poor behavior, so we don't get enough data from enough information, from the images to answer the questions, or because the solutions cannot be installed in production for other reasons. Many times because of organizational reasons. Because adopting modules that are based on artificial intelligence is not always easy for organizations. So around 50% of solutions that are developed with artificial intelligence don't move from pilot to production. And this is a problem. But this number has been increasing during the years because everybody has learned how to transform some way those models that are developed in the lab, that are validated with a pilot, to production with a good industrialization process. Anyway, many of the modules or models that move from product to production require a lot of maintenance. Why? Because there are many aspects of the solutions that are not present when we work in the POC and the pilots, that appear when we go to production, and that they require attention to be solved, and that transforms, or that is why they require a lot of maintenance. Anyway, today, to be honest, many modules are moving from the first phases to production. We are talking around 50%, and that's a good number. So if we talk about analytics, and that's the main reason of this session, solutions today in analytics are growing. There are many solutions around analytics in retail. So, for example, I'm going to show you a couple of them. I'm going to talk about one solution we have that is called CPG Analytics. In this case, what we do is we detect products in shelves to make sure that the products that must be there are actually there, what we call compliance. And that way, a producer or a distributor can know if their products are really in the shelves of the supermarkets where they should be, and that they are placed in a way that is the better to promote selling those products. That's what we call compliance with planograms. Planograms are a design that many companies do on how the products must be placed in the shelves. But many times supermarkets don't comply with these planograms. Products are not in the place where they should be. So with artificial intelligence, what we do is we capture images of the shelves, and the system detects where each product is placed and the correlation with the planogram. If there is the product is in the right position, if the product is not in the right place, or if the product is not in the image. That way, the producer, the manufacturer, or the distributor can take actions to make sure his products are in the best disposition in the shelves. This is a solution that we have in some customers. In this case, the images are taken with mobile phones, and the process is done, can be done locally with edge devices, with servers, small servers that run on premises or in the cloud. Another kind of solution that I wanted to show you is what we call a self-checkout production solution. So, Propose, this is the solution I am presenting you. It's a self-checkout solution for restaurants and canteens. What we do in this case is, in a canteen or a restaurant, customers come with their trays. They put their trays under the device, under the cameras of the device. You can see the device in the image. And with the cameras, we capture the plates that are in the tray. We process locally those images, and the model detects each plate, making the process of ticketing, creating the ticket automatically. So the customer can pay without the presence of a cashier. It's a self-checkout system for restaurants and canteen. And here, the difficulty is around detecting plates, because many food plates, main food dishes, are very similar, and there can be a difference in price, there can be a difference in size, and the system has to be very, very precise on detecting those plates. So I'm going to show you a video on this solution. In this case, this is the device. And as you can see, the customer takes the plates he wants. He places them in the tray, on the tray. The tray is under the device captures the images, and instantly the ticket is created. The customer can pay, and automatically the transaction is closed, and he can leave. This solution can be applied to plates, but it can be applied also to other products. In this case, instead of plates, we are talking about snack products. So the system is the same. Without a tray, the system can recognize the products, and the checkout process is totally automatic. These are the kind of solutions we work at Pervasive Technologies, and I thank you for attending my session in this tech forum, and I hope you enjoy the rest of sessions. Thank you very much. Have a nice day.